Welcome all. So last class we discussed about the mesh analysis. So today's class we are going to discuss about nodal analysis. So nodal analysis, which is similar to your mesh analysis, it is also used for finding the node point, nodal voltage. In mesh analysis, we are finding loop current. So both the method we can find the unknown value, branch current or voltage, whatever parameters you want, you can find the value both the methods. But the steps will differ. In mesh analysis, we will apply KVL. Here we are applying KCL. Okay. So this is the given circuit. So your step 1 is step 1. You have to identify how many nodes in the circuit. So before that, you have to know what is node. So more than 2 branches meets at one point, we can call it as node. So you are not considering this as a node because here only 2 branch, right? The source voltage and then this 4 ohms meet at one point. This is not a node for this. So this 4 ohms and then this 8 ohms, this 10 ohms meet at one point, called as node. More than 2 branches meet at one point, called as node. So here I am going to mention V1. Similarly, if I am considering this point, this 10 ohm resistor, this 2 ohm resistor and then this 4 ohm resistor meet at one point is called as node. This is V2. And then one more node is here. You have to mention the reference node. Here the reference node is ground point because all the branch meets at one point, called as ground. So you have to mention the reference node also. V3 equal to 0. This is reference node. You have to consider only these two nodes, 2 voltage. This V3 equal to 0 because all the branches which is going to ground, V3 equal to 0. You have to find out what voltage at this node and then this node. If you know the voltage across these two resistor means you can easily find out the current flowing through this 10 ohm resistor. So now you have to identify how many nodes in the circuit. Actually it has 3 nodes but one is reference node. So 2 nodes, V1, V2. Next, step 2. So you have to label as nodal voltage V1, V2 and V3. So actually the total node is 3. So V3 minus 1, it will become total nodal voltage is 2. It's nothing but V1 and V2. Step 3. So like mesh analysis, here also you can go with 2 methods. You can use inspection method also or you can go with applying KCL also. I am going to apply KCL at node 1. It means that V1. So you know very well KCL is nothing but Kirchhoff's current law. Kirchhoff's current law says that the entering current at the node which is equal to leaving current, or the algebraic sum of the entering current plus algebraic sum of the leaving current equal to 0. So I am going to assume the branch current here. This is I1 and then this is entering. In this node the arrow ends at here, right? So here also one branch, this current will split into this direction as well as this direction. So I am going to assume this is I2. Then this current from the node it leaves, right? So this is I3. Similarly, if I am assuming this node, the entering current is I3 only, right? So here the leaving current is I4. Similarly here I5. Okay. So apply KCL at node 1. I am going to consider this V1 only. So I am going to apply Kirchhoff's current law. What is my entering current and leaving current? So algebraic sum of the entering current is I1. This I1 enter at this node. I2 and I3 is leaving node. So minus I2 minus I3 equal to 0. This is equation 1. So I1. So all of you know very well by Ohm's law, I equal to V by R. So I1 equal to, you have to check this I1, it will start with this source voltage 8 voltage and ends at V1. So starting voltage you have to mention positive, ends at V1 is nothing but minus V1. So 8 minus V1 by the resistance mentioned here as 4. So all of you know that I equal to V by R. So each branch current I am going to mention what is V by R. So V here the entering voltage from the source 8 voltage and ends at V1, you have to put negative minus V1 divided by 4 is your I1. Similarly for I2, this is V1, entering voltage is V1, this voltage, this ends at 0, right? That is nothing but V3 minus V3 is 0 divided by 4. So you can also write like this, right? So V1 by 4 because V3 was 0. V3 is nothing but 0 because that is the reference voltage. Similarly I3. So I3, it starts with V1 minus V2 by 10 ohms. So for I2, V1 minus V3, the resistance value here mentioned as 8, right? 8 ohms. I2 equal to V1 minus 0 divided by 8 ohms. Similarly, for I3, V1 minus V2 divided by 10 ohm. Okay. Now I know what is I1, I2, I3. You just substitute I1, I2, I3 in equation 1. So 8 minus V1 divided by 4 minus, so if you are simplifying this, 8 by 4 minus V1 by 4. Similarly, here I2 minus V1 by 8 because here 0 by 8 will become 0 only. So V1 by 8 is my I2. So minus I3. I3 is nothing but V1 by 10 minus and minus will become plus V2 by 10 equal to 0. Then 8 by 4 will become 2 minus 1 by 4 is nothing but 1 by 4 0.25, right? So 0.25 V1 minus 1 divided by 8. So 0.125 V1. Then minus 1 by 10 is nothing but 1 by 10, 0.1. 0.1 V1 plus 0.1 V2 equal to 0. Okay. So if you are adding all V1 voltage value, it will become minus 0.25 minus 0.125 minus 0.1 minus 0.475. 2 minus 0.475. Then plus, this is V1, right? V1 plus 0.1 V2 equal to 0. So, I am going to take this value to left hand side. So, it will become 2 equal to 0.475 V1 minus 0.1 V2. 0.475 V1 minus 0.1 V2. So, this is equation 1. So, similarly, I am going to apply KCL at this node V2. So, step 4, apply KCL at node 2, V2. I am going to apply KCL at node 2. Here, you know very well, Kirchhoff's current law says that the entering current equal to leaving current equal to 0. Here, the entering current is I3 and then I4, I5 is leaving current. So, you can write I3 entering current minus leaving current minus I4 minus I5 equal to 0. Equal to 0. Okay. Now, you have to find out what is I3, I4, I5. So, I3. So, this is your I3 current direction. It will start at V1 and ends at V2. So, you can write V1 minus V2, V1 minus V2 divided by this resistor value as 10. Then I4. So, I4 here. So, the entering voltage, this voltage, it starts at V2, ends at V3. So, V2 minus V3. V3 is 0. So, V2 minus 0 divided by this ohms. V by R, right? So, V2 minus 0 by 4. Then I5. So, for I5, the entering voltage is V2 and then here also one source voltage is there. So, V2 minus this source voltage as 4. So, V2 minus 4 divided by this resistance as 2. So, now I know what is I3, I4, I5. You just substitute I3, I4, I5 at this equation 2. In equation 2. So, I3 is V1 by 10. Then minus V2 by 10. I4 minus I4. So, here V2 is there. So, minus I4. So, minus V2 by 4. 0 by 4 will become 0. We no need to bother about this. So, V2 by 4. Then minus V2 by 2. This minus and minus will become plus 4 by 2 equal to 0. So, I am going to simplify this. This will become 2. So, 1 by 10 is nothing but 0.1 V1 minus 0.2 V2 minus 1 by 4. 1 by 4 is nothing but 0.25. So, 0.25 V2 minus 1 by 2 minus 0.5 V2 plus 2 equal to 0. Now, I am going to add all V1 and V2. So, here minus 0.2 V2 minus 0.25 V2 minus 0.5 V2. So, it become 0.95. Sorry, this is also 0.1, right? So, 0.1 V2, 0.25, 0.5. So minus 0.1 plus 0.25 plus, sorry, minus 0.1 minus 0.25 minus 0.5. So minus 0.85 V2, here 0.1 V1 and then plus 2 equal to 0. I am going to take this V1, V2 values to that side, will become 2 equal to minus 0.1 V1 minus, if you are taking that side, it will become plus 0.85 V2. So you just consider this equation as second equation. Now I know the two equations. So 0.475 V1 minus 0.1 V2 equal to 2. This is equation 1. Then second equation as minus 0.1 V1 plus 0.85 V2 equal to 2. This is your second way equation. So you can use your calci, press more clear. If you are pressing 3 times means it will show equation, matrix and VCT. So you are going to solve by equation. So press 1. It will ask how many unknowns. You just press 2 plus the coefficients of A1, B1, C1. A1 value coefficient is nothing but V1 coefficient. So A1 is 0.475. If you are pressing equal to, it will ask B1 value. So minus 0.1 equal to C1 value is 2. Then A2 is minus 0.1. If you are pressing equal to means minus 0.85. C2 is 2. So your I1 value is 3.62. I2 value is minus 2.77. Now I find current value I1 and I2. Sorry, V1 and V2. V1, V2. So once you know V1, V2, you can easily find out what is the current flowing through 10 ohm resistor. So I3 is nothing but V1 minus V2 divided by 10. So I3 is nothing but the current flowing through 10 ohm resistor. So V1 3.62 minus will become plus 2.77 divided by 10. The current flowing through 10 ohm resistor is 3.62 plus 2.77 divided by 10. 0.639. 0.639. So the current flowing through 10 ohm resistor is 0.639. So using your voltage and resistance, you find your unknown current value 0.639. So this is how we can solve using the nodal analysis. So you can solve by inspection method also. Thank you.